All right, welcome guys. My name is Precious. Welcome to my channel. Please do well to like, share, and subscribe to get more videos like this. Now, today we'll be talking about profile of offset ruler. Now, earlier, previous to this, prior to this video, we did one on cam profile also, but it was with knife edge follower instead. Right, this is ruler follower. Now, there are basic things that there are some similarities between them and just one or two differences, just slight. How do we get to that? All we know is this, that the let's go through this question. This is a question we're actually going to use for the ruler. Now, for the ruler, we said 0 to 60 is the dwell, all right, 60 to 180 is the lift, of 36 millimeter with simple harmonic motion of what 180, with simple harmonic motion. So there's a lift of simple harmonic motion. Then we have 180 to 360 fall to the start position, meaning it's another fall of 36 millimeter with a simple harmonic motion also. Now the cam rotation is anti-clockwise. So if the cam is rotating anti-clockwise, we know that whatever follower is going, because we have the knife edge follower, we have the flat follower, we now have the roller follower. Whatever follower is going to be present there will be in a clockwise motion, right? Since the cam is anti-clockwise. If the cam is clockwise, then the follower will be anti-clockwise. Now, nearest approach of the roller center to the cam center is 38 millimeter. Now, the roller follower is this part, the nearest approach of the roller center to is what we call the thickness circle, or the thickness of the cam itself. Remember, in from a previous video, we said we have the circle diameter, the cam diameter, we have the thickness diameter, then we now have the extension, which shows the lift or the fall of it, right, of the cam data. Now, let's say that the roller follower is 20 millimeter in diameter and the follower line of action offsets 20 millimeter to the left. So now this is not even starting from the center point, 0 point, starting 20 millimeter to the left. We'll treat this part now of this cam center line, and the camshaft diameter is what, 24. So without much delay, let's get into it. The cam data, or the camshaft is 24 millimeter. That's the size we have there. Now the thickness we said is 38, right? Oh, sorry. The camshaft diameter is 24, so um the radius will be 12. Good. Then we have this, the thickness, which is 38. That one will be in terms of radius. Now we now want to include the extension, right? Now that extension will be for the cam data, where we'll trace out the line of the cam data from. Now, and to do that, we know that from here to this point is 38, and from the question they said it has, you have a lift of 36, so we'll just do 36 plus 38, and that's going to give us 74, right? So we'll draw another circle of radius 74 millimeter. 74 millimeter. 74 millimeter. Good. So I believe we are good with that. Now the next thing we have to do is to follow this part that says the nearest approach of the ruler center to the cam is 38. Yes. Now we said that the follower line of action offsets 20 millimeter to the left of the cam center line. What that part means is this, all right, and that's going to give us make us draw what we call the follower circle also. Now we'll just have from the center of the camshaft 20 millimeters to the left. So we have 20 millimeters to the left here. All right. Now the next thing you're going to do is just trace these 20 millimeters up. Now what this does is this point here and this point signifies your zero or starting position. Remember from knife edge followers, what we just did is this straight, right? We just did this one straight, and we said this is our zero position. Then we started labeling 0, 15, blah 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 till we get to 360, right? But in this case, this is our zero. Our zero starts from here and this point, because it's 20 millimeter from the center to the left. Sometimes it might be to the right. All right, good. So we have that. Now the next thing for us to do is to draw a circle. All right. Now this circle will have a radius from this point to this point. Now this part is peculiar to only, now please listen, it's peculiar to only ruler followers, not knife edge, not flat. Now we've drawn this circle. This circle is called the follower circle. All right, it's called the follower circle, but it also shows the direction. It's going to allow show the direction of the camshaft. Now, how do we um deal with this, or what do we do about this? You see this circle now, this line now, we're going to divide it into segments. Now, do we use 15 or do we use 30? If we use 15, for this video, for the context of this video, please, I will use 15. Sorry, I'll use 30, but please, well, to get a more beautiful work and the likes, you can use 30. All right. So we say 360 divided by 30. That will be 12. So we need 12 of these lines. So what you just do is you come to your array here, your polar array. All right. Center of the array line is here. Then we come here and change this to 12. Change this to 12. So we have this. All right. You can change it to, if you want to use gradient of 15, I mean 0 to 15, to 30 to 45 till you get to 360. All you just need to do is make this 24. All right, you have this, but let's make it 12. All right, for the length of this video, I would love to use 12. Good. So what we know is we've gotten this, and the next thing we are to do is you will also want to show where these lines are coming from the cam data parts. All right, now how do you do that? Well, this is what I would just do. If it were me, I would create another line here, from here to this point. Good. Now I'll click on this line and also come to the profile, sorry, to the array function, and click on this as the center, and then click on this to be 12. Remember, we use 12. Good. So it just helps you show that from the center you have each of these lines. All right, you can as well do the full line. All right, it's basically up to you. All right, different people with different designs. I just love to use this part. Now the next thing for us to do is to get our profile, right? Our cam profile. Now remember, this is our 0 comma 360 degrees. Since the camshaft is going anti-clockwise, the numbering will be going clockwise. So basically, I guess that what we'll do is this. We'll have 360. Let me use as 360 comma 0, small. So what we'll just do is simple. We have this. Then we'll come here to text height, and let's make it 5. Good. So from here, we just drag this here, we drag this one here, so we know that this. The reason why I started with 360 first is because when we are numbering, we say 0, 30, 60, 90, like that, like, so we come to 360. That's what I just said, but I want this point shown. Now the next thing we have to do is to draw our cam data. We've drawn our displacement to a point, so the next thing is to draw our cam data. All right, how do we do our cam data? Let me use 250 length of, now this 250 is just of any length. All right, you don't actually need a specific length. You can use any length of your choice. Now we have to offset this. All right, we're going to offset it by what? 36, by 36, because the lift and the fall from the question is 36 millimeter, right? So we have that 36. Good. So we've had this line. So the next thing for us to do is to draw our what? Our cam profile from this one. Now how do we do that? All we just need to do is let's do this. Good. Then we start offsetting this line. Can offset it. Remember, we have to offset 1, 2, 3, 4. We have to offset 12 of these lines. All right. So how do we do that? It's very simple. We'll come here. We'll come here. Sorry, here. Select distance of offset. Let's see what 5 would do. Good. Since we're using 30, I believe we should use a larger distance. instead of 5, normally I use 5, and since this is going to be much, let me use 9. Let me use 9. Hmm. No, I need something quite large. 0 to 60, because we have 0 to 30 to 60. Let me use 12. Now this spacing is of should be of your own choice. All right, there is no specific, but I want my graph to be large. All right, I want it to be big. That's why I'm using this. So if I decide to use 12, all right, we have this for 12, we have this again for 12, so we're making 12 of it, right? So 1 0 1 2 3 4 5 6 7 8 9 10 11 and 12. So invariably we have 13 lines. All right, we have 13, but I said 12 because we have 1 0. We're starting from 0 0 1 2 3 4 5 6 7 9 10 11 12. Good. Now the next thing for us to do is to watch the lift, right? Since this is our zero line, all right, we can as well do the labeling of it. We have 0 degrees, from 0 degrees to um to 30, to 30 to, let me just put the next one as 90. Then I would jump to 180. 180. Then I'll jump to 360. So all these ones I'll just highlight them, and I'll come here and say text height. I made it 5, right? Good. So I'll drag each of these lines to this point. This is my 0. Oh boy. This will be our 0 line, 0 mark. For this will be 0 because we're using gradients, the gradient system of 30. This will be our 30. After 30 plus that will be 60, but here we'll have our 90 here. 90, we have 120. 120 plus 30, 150. 150 plus 30, 180. So we'll have it here. Then finally we'll just have 360 here. Now please, for anytime you're solving this question, you have to submit it. Please make sure you complete it, right? For just the sake of this video is why I'm doing this. So we've done it to a point. Yes, so we know 60 is here. Good. Let's see. I think I'll have to do that of 60. 60. Okay. 5. 60 is here. All right, good. So we know we have this. Now the next thing for us to do is this. Now let's start with the question. Now the question here says that from 0 to 60 is our dwell period, right? Yes. So we have a dwell period of 0 to 60. So what we're going to draw is a thick line from 0 to 60. We can use spline. All right, we can use spline from 0 to 30 to 60. All right. From there, we will just hold it off for now. The reason why I say hold it up is this. We'll pick that line. It's actually going to be a straight line, so we don't actually need spline for that, but you can just still just leave it. 0 is supposed to be a straight line, 0 to 30, because it's a dual from 0 degrees, starting from the 0 degree mark, so it's going to be just a straight line. So what I'm going to do now is this. I'm going to the line weights, I'm going to make that a bit thick and make the 0.6. Put this on. Good. So we have that. That's the dual, right? Now the next part is this. They said a from 60 to 180 we have a lift of what? Of 36 millimeter with simple harmonic motion. Now remember when we said if we want to draw simple harmonic motion, we need to start with what? A semicircle, right? Now because uh from the question we said simple harmonic motion also a fall with what? Simple harmonic motion. So our work is quite what? Easy. So from 60 here to this 180 is simple harmonic motion. From 180 down to this point is also simple harmonic motion. So what do? We come here. Earlier on we draw a circle of this radius, right? We trim this part off, or you can draw an arc, alright? Depends on you. I decided to just draw a circle. Now we divide this line, alright? Normally we're to divide, if we know, because we're using 30 30 30, it's supposed to be 12, so half of this 12 is supposed to be 6, right? So if we say we are to divide this line into 6, let me see. So we are to divide this line into 6. I'm coming out, so I'll have to remove this line, this one, to erase it off and draw another one. Okay, good. Now we're supposed to draw 0, 30, 60, 90, 120, 150, 180. That's 6, right? 1, 2, 3, 4, 5, 6. Alright? But we're going to add 180 again, which is what? 7. Alright? That's the main reason why I said 7. 0, this is 1, 2, 3, 4, 5, 6, 7. Alright? Because we are also including 0. Alright? 0 to 10. Alright? We know we have 1 to 10 basically, but when we're counting 0 we have a total digits of what? 11 digits. All right, but we are counting from 0 to 10. That's just it. So for this we're going to add one more based on 0. This is be 1, line 1, line 2, line 3, line 4, line 5, line 6, line 7. So we're going to array this one. All right, center point is this, and instead of 6 we use what? 7. Good, we've done that, right? Oops, sorry. So 7 lines, but there is also a slight problem. Instead of, we don't need it full, we need it at this point, right? So because we need it at this point, instead of 360 we change it to 180. Good. So we have this already, and that's this. It's as simple as that. So now what we do is this. All right, for this part, the labeling, we have 0 degrees, we have 30, we have 60, we'll have 90, and go till we get to 180, which is at the top. So this is our 0 degree. All right, it will still meet at this point. Our 30 degrees will come here. 0 degrees is from 60, right? 0 degrees 60. The next one will be to 90. Please make sure it's always going to be perpendicular. The next one is always going to be to this point, which is to 120. The next one will be to this point, which is 150. The next one will be to this point, which is 180. The next one will be to this point. Oh, sorry. Must have been a mistake. A rise. Sorry about that. Oh, the division of the line. I'm so sorry. It's not supposed to be that, since this is 12. Half of 12 is 6. So it's supposed to be 6. I'm sorry about that. The division is meant to be 6. Alright? Not this. Division is meant to be 6. Half of 12 is 6, yes. So we have 1. Okay, so we have 1, 2, 3. So half of 6 again is also 3, but because of 1 we have 4. Good. I'm so sorry about that. We are just meant to do this. Alright. Remember the gradient system we're using, or the gradient segment we're using is 30, not 15. If it were to be 15, that means we're supposed to have 24 lines all over. Then half of that, or half of that will be 12, and we'll have 6 here. So we'll have 1, 2, 3, 4, 5, 6. But what we are dealing with is from 60, all right, to 180. From 60 to 180 is how many lines? 1, 2, 3, 4, 5, right? 5 lines. So basically, we know from this point 0 to this point, this to this point, 60 to 180. So that will be 1, 2, 3, 4, 5. So basically, the number of circles we are supposed to divide this into is supposed to be 1, 2, 3, 4, 5. So we're supposed to divide this into 5. Sorry about that. So we're supposed to divide this into 5. So what this will mean now is this. Please pay attention. We're not still lost. Remember we did 0 to 60 here, right? So we stopped here. Now from 60 to 180 is the lift. Because that's the lift, we're only going to divide this circle by the number of lifts we have here, by the number of lines of the lift we have here, which is 1 from 60, 2, 3, 4, 5 to 180. So we divide that. So we'll have line 2, line 0 here, the next line 2, next line 3, next line 4, and next line 5. So we'll have that. So what we just need to do is extend these lines instead. Extend these lines. Remember, the first one is from 60 to 180. So 0 here will be from this 60. So the next one should be from this one to this point. From this point here to this point. Good. Then the next one will actually be from this point to this point on top, 180. So that is it. So the one we have to use now is spline. We have to use spline. Alright. So spline will start from this point to this point to this point to this point, then to this point. So the spline line, we can increase the weight, line weight to 0.6 was what I used. Now you can use this spline because it's not really looking that good. You can decide to just come and use this arc. Alright, 3 points. So have from here to here to here. And we'll continue again from here to here to here. So we have this arc and we have this arc, and we increase their line weight to 0.6. Good. So we have that. Alright, good. Sorry for the confusion earlier. Sorry about the confusion earlier. So the next one we have to do now is this. We have a fall based on this question. We have a fall of to the start position, meaning it's falling back from 36 to 0. All right. So how do we do that? Now we can't use this same circle. Why? Because from this point we have how many lines? 1, 2, 3, 4, 5, 6, 7 lines. All right. We have 7 lines. We can't use that circle because this line only has what, 5. So to use the one of 7, all right, we can do that at this point. Draw another circle, trim this one to make it a semicircle. We trim this to make it a semicircle. We erase this one, and we draw another line from here. From here, then this one is the one we will now offset. Sorry, we'll array this. Center point is this. Remember we said 7, right? 1, 2, 3, 4, 5, 6, 7. Good, 7 lines. So we come here, 7 lines. All right. Now we don't need it to be reset, we need 180, so just say 180 and press enter. Now it's at this side, all right, we need it to be at this other part. So what do? It's actually quite simple. We Let's leave this part for now. Good. You can just change the direction from these points, all right. You can change the direction from these points. Good. So we are done with this part. Now remember again, we are coming from 180 down to where? 360, right? So we extend lines again. This line is to this point, all right. So for this line is to this second one. We draw another one. This line is to this point, be to this point, all right. Good. We draw another line again from this point to this point, all right. We draw another line again from this point to this point. We draw another line again, should be like the last line to this point. Good. Then we use arc, right, and trace these points down. 2, 3, arc again. 1, 2, 3, 3. Where is it going? Okay. And I guess we'll use line here in this case. Oh, I'm coming, please. Let me try something. Uh, let's see if this should give us the same thing. All right. Nah, it's going to be different. Sorry about that. So let's use spline then. So we have from this point to 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 this point. Or we can do it this way. Sorry, I'm so sorry. We can do it this way. These 3 points. Spline always looks a little bit rough for me. That's why I'll just come here and use continue. Still use continue. Still use continue. Still use continue. So just click all of this. You can see use spline, please. It's definitely no big deal about that, but personally makes it look particular way. So this is what we have. All right, this is simple harmonic motion for the lift, and this simple harmonic motion back to the 4, and this is the point where they meet. This is the 180 point. So we've drawn the cam data. All right, the next thing for us to do after drawing this cam data is to draw the displacement diagram now here. Right, now remember, is a roller follower, and they told us something. I want you to keep this in mind. They told us something. They said that the roller follower is 20 millimeter in what diameter. Now for knife edge, we know we don't actually have to draw anything, but for this we need to draw something. What we are going to draw is this. Since these are 0.0, now notice these are 0.0, right? So we're going to draw a circle from this point, all right, of diameter 20. It means it will have a radius of what? 10. Good. Hope you guys are following. So have a radius of 10. We're starting from where? This point, right? Good. Now, from the graph here, we know we're starting from 0, and because the cam is moving in this direction, the follower will be going in this direction. All right. So that means for this, we're going to 0 to 60 will still be on 0 mark. So this is our 0 mark, 0 to 60. So that means the next part, come in please. That means this will be our 30. Remember where I said the copy here, and we'll do this too. Copy here, and we'll do this too. Copy. Good. So we know that from 0 to 60 is a dual. They are, all of them are still going to be on what? Zero mark, right? So because all of them are still going to be on the zero mark, we'll do the same thing. We'll set this here. So using 10, draw another one here on the 60 mark using 10, radius of 10. Good. So we have this from this part to this part to this part. Now from 0 to 9, from this 60, we started having an increase. All right. Now all we need to do is please just come and measure this line from here to here. Let me drop it by this side. This number is not too big, safe. All right. Let's do this. Okay. I'll drop this one here. So this for the first line, this for the second line. For the third line, I'll just come here and use this. Good. So we know that since this one is this one will be 36 definitely, because there's no actually need to check it, but if you want to just confirm, it should be 36 definitely. All right, 36. So we don't actually need to do that. So now what we're now going to do is transfer each of these dimensions. This one is 5.2721. We're going to transfer it here at this point. All right, starting from here, this is our point 0, right? This line represents our point 0, so this is what we're now going to do. 5.27, what was that again? 2721. Okay, so draw a line. This is where I have to increase the line width 0.4. 5.2721. So I'll just use this and say 5.2721. Okay, that's that point. The next one I will say is 18, and the next one is 30.7279. The next one is 18, so we'll just say 18. So this one is I'll just drop it here and just type 18. Alright, so we have this, and the next one is 30.7279. 30.7279 will look like this. What you just do is you just come and leave your mouse, your cursor here at this point. All right, then you press 30.7279. 30.7279, press enter, then you have this. All right, was that right? 30.7279, yes, good. Then the next one they said is what? 36, right? That one will be the full length from this point to this point. All right, that should be 36. Let me see. 36, 36, 36, 36. Good. Then the next one, that's this. After that, we'll move to the next one. So I believe we don't need this, or this again. Next one will be, that's this for this line. Then we'll do for this line. Oh boy. $27. From 27 we'll have 18 again. We'll have 9. Let me drop this here. 2.4115. So this first one, let's continue with this. We have 33.5885. 33.5885. So we'll come here. 33.5885 will look like this. 33.5885. Yes, should look like that. Then we have 27, 18, and 9. So that one is simple. 27 should be from here. Then I'll leave my cursor here. The reason why you are doing this is because so you can still get that angle. All right, the angle here. Here is 179, 180 is just shifting. So here we have 27, 18. Oh boy. 27, 18, 27, 18, and 9, and 9. Alright. So after 9 we have 2.4115, and then we have 0. So 2.4115, 2.4115. So now this is what we're now going to do. For each of, or each and every one of this drawing, let me return this back. Good. Now for each of these points here, we are just going to draw what? A circle. A circle of radius 10. Remember the diameter is 20. So we're going to draw a circle of radius 10. Radius 10. This part too. Radius 10. Radius 10. Oh boy, sorry about that. Radius 10. Radius 10. Radius 10 for this two. Alright, now good. So now we've cleared it to a point, right? Now the last step for us, or the last stage for this question, is where we'll pick. We're going to draw like a curve round through the base of every one of this circle, right? So you can use spline. In this case, you can use whichever. You can use arc also. All right. I just prefer using arc, but if you want to use spline too, it's acceptable. So from here, this is what we're going to do. It's going to start from, let's use spline. From this bottom here, remember this is our 0, right? This is our 0. From this bottom to this next one, to this next one, all right, to this next point, to this next point. Oh yeah, to this next point. Please, you have to be careful about this. Good. To this next point, to this next point, to this next point, to this next point, then down to this next point, to this next point. It's just the bottom of those circles, all right, to this next point, and back here. So we have that. So we've completed one thing. We've completed the displacement diagram. Also completed the cam profile. All right. Sorry, let me remove this since we don't need them anymore. And this one too. Whoa. All right. So we've completed each and every one of these. All right. So this is just how you are going to draw this. This is a follower. All right. The follower, the difference between knife edge and follower is this. Follower, especially if they tell you for knife edge too. All right. If they tell you that the position of the knife edge offsets to a particular by a particular distance, this is this tangent lines is what you will have also. The only difference between knife edge and follower and ruler, all right, and ruler follower is that For knife edge follower, you're not going to have all these circles round. All right, you're just going to trace the top of these lines. The top of these lines is what you're just going to trace with this curve round. All right, but for roller, you're going to draw this circle and you're going to hit, make sure this curve pass through the bottom of every one of these circles round. So this is it. And please, you have any questions, please do well to drop it in the comment section. I would answer. And please, once again, don't forget to like, share, and subscribe. I'll be dropping more videos soon. Thank you and God bless.